let's solve problem number 6. All right, we've got some input, some output. We're going to experiment a little bit with formatting our output as well as our input. All right, so we're going to write a program that formats this product information. We want the user to enter an item number, a unit price, and a purchase date. We're going to prompt them on the formatting of the purchase date as well. So let's just go ahead and get that input information. So we're going to have some variables as well to store that. All right, we're going to have something for item number, unit price, and then month, day, year. All right, it looks like item number can be an integer. All right, unit price, a floating point, or a double. Let's work with a double since we worked with floats in prior examples. And then let's use integers for the month, day, and year. So here in code blocks, I've already got exercise 6.c into my project environment. I've just got this blank shell. I copied the program instructions. Here's a comment. Let's just go ahead and declare our variables. So, variable declaration. All right, we had item number. We said that could be an integer. So item number. And then we said double was going to be the price. And then integer, we have month, day, year. But unit price might be a better name for that. What we want to do is then if we want to prompt the user to enter this information, we're going to need to print out these messages and then use scanf to read this in. So let's have them enter the item number. So here's our input section. Right? Most programs are input, process, and output. So we're going to display this message that says enter item number. No new line character because then we want to read it in. We want it to be on the same line so it looks a little bit neater. All right, so item number is an integer, so I can say %d here. And then just give this the address of item number. Right. And the next thing we want to do is we want to have them print in or enter unit price. All right. And that was a double, so %LF or a double long float. And then the address of price. And then we want to, like exercise 5, we want to enter the date. And we can give them a little hint here about the format, month, day, year. And D /% %D for the integer / %D for the integer. If we wanted to, we could run and test this much, right? Just going to say run to cursor, that'll build my environment, and I got some warnings going by, so let's take a look at the build log. Right, %D, matching an argument. Well, yes, so what happened was I've got some errors here. So let's stop the bug environment. So they came up with warnings, but I didn't say where I wanted to store things. So we want to store in month, the address of day, and the address of year, which is really why it's safer for me to just compile first. So let's compile before I build. Oh, it looks like the debugger thought it was still going. I'm going to remove that breakpoint. Debugger finished with that. Oh, sorry, back to my build log. All right, so it looked like everything. Build okay here. I'm just going to rebuild. So it's told me it was going to delete object files, executables. That's okay. It looked like everything built okay. Now, just put in a breakpoint here. I'm just going to right click and say run to cursor. All right, so first thing that pops up, item number. Well, our example I think was 583. our unit price, 13.5, and month was our example. Maybe we'll do the 1/25/2015 or 14. All right. So I read everything and stored it in those variables. We're going to type things correctly. We're going to assume the user is going to pretty much type everything in correctly in order for our program to create the output it should. I'm just going to hit this to stop the debugger. I'm going to right click on that. I thought remove the breakpoint, but it's not important. Let's take a look at our program. All right, looks like this used the date of 10/1/24. Our output, the item number and date should be left justified. So we want to then create something that sort of lines up. Right, we want to have item, unit price, purchase date. So we want to have some headings. Right? So we're not going to have any process in here. We're just going to have some output. So display. We're going to display column headings. All right. So on one line, right, it looks like we have unit and purchase. Right? And we want to put some thought into this normally, right? If I were to just say print unit, maybe space, purchase on one line, and maybe let's do that. Maybe let's give this a couple of blank lines before we get there. All right, if I just type something like this and then I say, oh, the next thing, right, we saw here was item, price, and date. Item, price, and date, and then maybe a couple of new lines. If we do this, and actually I don't really want to run the input now. I'm just going to comment out this section on the input. I just want to take a look at my output. So let me build and run this. I got some warnings here because I'm not using variables. You can see that doesn't line up nicely. Unit ends up over item, right? Purchase ends up over price instead of date. So we want to think about how we want to display our output. How wide are these fields going to be? And then determine our headings as well too. Where will they go? All right. So the unit price should be right justified. I want the item number and the date to be left justified. So if the item number is to be left justified, right, leftmost column, well, we need 4 characters here just for the word item. And then depending on how many spaces we want to leave in between, there's different ways we could do this. We could actually make the unit or the field width for item. What if we made it 4 spaces for the item number and another 4 over to unit price? So what if I actually then, for item number, said let's print out %8D. Now if I do that, that's going to be right justified. Or I want to left justify this, so I'm going to put a minus sign. -8D, new line character, and let's just print out the item number here. Now, let's temporarily hard code in that 583 to initialize it with that. I'm getting some warnings about unused variables. Notice I've got the 583, it's lining up here under item. So we're going to use 8 for the item width. All right, when I print out this, there's different ways I can do this to print this out. If I wanted to, in this specifier here, what if I said %8? We haven't talked about string data. What if I had %8s here? So 8 is my field width. SN is for string. So now, here I'm going to put my string item. And now if I build and run this, we want to normally be a little more organized about how we do things, but we're learning, so I'm doing this one at a time. Well, notice item's all the way over here, but it's right justified. So if I want to left justify the word item, I need to go ahead and put the minus sign here. So this is left justify. Use a field width of 8. And string means a set of characters inside double quotes. So it's going to take this argument here, this set of characters inside double quotes, and then substitute that in here for the %s for this specifier. And then I can do the same thing for price, for that string, price, and the same thing for this string, date. Instead of trying to type all this in and use spaces and tabs and things like this. So how wide do I want to make the unit price? Let's look at our specs. Allow dollar amounts up to $9,999.99. Now, are we going to show the dollar sign? That's probably up to you as the programmer. You can see in the example output I gave you, we are showing the dollar sign. The unit price should be right, justified. Right, so we type that. So let's just go ahead. Maybe we want to left justify our field. So we've got 1, 2, 3, 4, 5, 6, 7, 8. 8 characters there with a dollar sign. So we need that to be 8 wide. And then maybe we want to leave some room to the right, maybe another 4 spaces. So if I say % minus 8, sorry, 12, S for string, sorry, %, I'm in item number, and I want to work on price. So I want here, I want this to be %s is for string. If I want the field width to be 12, and then I want to left justify the title, I do this. Same way for date. Date is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wide. So if I want that to be 10 wide, %10s for that string. If I want to left justify it, I can do that. And now we're going to see item price and date. Let's clean up unit as well. So let's put a string out here that says unit. We want a string for purchase. So we're going to get rid of unit and purchase in here. We're getting rid of the string information in here. We're going to need a %s. Unit, well, we just said the unit field should be 12 unit price minus for left justify. We said % minus 10s for purchase date. And then we have the item number. Well, that needs to be blank space. So what if I put just a simple blank space or an empty string? I could just have empty double quote. And now what if here I say % minus 8s. So let me get rid of these new line characters. Notice how I made these 2 column headers match. Right? If I want a couple of new lines in there, I'm going to do this. Let's just do a build and run and see how this lines up. All right, everything lined up pretty nicely. So notice I had this empty string or this space here. It's really not an empty string, it has a space, but it says I want you, my string is a space, but I want you to use 8 of these. Left justify it, so it showed me space out to the left. So that's why I got these 8 spaces here. And then it started with unit all the way over here at 12. So we want to line up our column headings. We want to put the information out here in strings, the strings of characters that we want to display. We use %s for the string. We use the field width in the same way. Things are right justified by default. So we use the minus sign to left justify. We use new line characters to just kind of space it out and make it look nicer. All right, so now I've got my column heading showing up. I've got my item number. What about my unit price? My unit price, dollar amounts up to $9,999.99. So I want to put in that dollar sign. And I want that field to be, well, there's 4, there's 6, there's 7 characters with a decimal point, so 7.2. That's how many spaces I want. I want 0.2. But now that 7 is not going to match up to the 12 that I used for the field width before, right? And it's going to right justify. Well, let's just go ahead and show the price. So let's default here 13.5. A lot of times when you're testing, if you want to make your output look nice, just go ahead and use some default values for these variables and don't keep running the program over and over having to type in all that information. That'll usually help you get your program, get your output looking better, faster. All right, so now I got 7.2. All right, why did I get 7.2 here? Well, because I typed 7.2 and I left up the specifier. All right. So now if I say percent, right, F for the float, and now if we build and run, so I get talking, and sometimes don't pay as much attention. So there's my 13.5. Now that's right justified. So it said the unit price should be right justified. That looks pretty good in that field. All right. Now notice it didn't match the field width of 12 here, so we might have to deal with that on the purchase date, right? Because we've only accounted for, with the $sign and the 7 here, we've accounted for 8 spaces, this had 12. So there's different ways that we could deal with that. I could make this, if I wanted to match that 12. I want to deal with the spaces. I don't want to make this any wider. If I do, I'm going to right justify this too much to the left. So if you think about it, I'm using 8. If I made this 11, did a build and run, and this is still running, so I have to stop it. I do a build and run here. Right, notice that right justifies it too much all the way over the start of purchase date. I want to restrict this to the 7 that we had here. So I can do Control Z to get back to what I had. And then there's different ways I can handle this. I can actually then put in, well, we were missing 4 spaces. I could just type those in the header. We can say %S. And I can put my 4 spaces up. Actually, I can just put my space here and make this 4S. Right? This is looking kind of messy. And then if I want my next field to be the date, well, then I got 2 for the month. So %2 D for the month / %2 D for the day. So 2 with D decimal, right, integer, / %4 for the year. So 4Y, the integer value of year. All right, so now I have month, day, year. And let's just go ahead and hard code some information in here. So that was 10. This was 1. And I'll make this 2017. All right, so I've got 10/1/2017. Now, notice it doesn't zero fill for me. I might want zero fill just to look nicer. Right, go back to our example. Notice how that was zero fill. So how do I zero fill something? Well, that is another modifier we want to use. So back to our example of C++.com. I went here in a previous example. So I went to C++.com and I typed in the word printf here. So once you go to C++.com, you type in the word printf, you say go. I'll do it again. It's going to bring me back to the same page. So that seems redundant, just to show you how I got here. Right, here's all these different specifiers. So this tells you how it's going to interpret information. Right, here are the different flags that you can use. So now if you want to left pad a number with zeros instead of spaces, you just fill in a 0 before that. So let's just go ahead back here. I need to shut this down. Right, now, I wanted to left pad, I might want to left pad this, the months, right, in case it's a 0. A month with less than 2 digits, and I'm going to put a 0 here for the day. So now let's build and run. And notice my day got 0 filled with 1. back to our problem here, right? You might decide you want more spaces over here. I've got a little bit closer than what it was in this example, but that's up to you as the programmer. We allowed the dollar amounts up to $9,999. The date should be left justified. All right. So we want to take care of the date being left justified. If our field width were more, and I shut that program, then I could do this here. Right. By actually using this 4S, then along with this blank space, my date ends up left justified under here. By the way, I've done this. I actually don't need that flag in. If I put the flag in, build and run, does it change my result? Well, I need to stop this from running. And notice that doesn't change our result. Oh, we get the same thing. All right, so we got our formatted output. Now we can test with different inputs. If you want to make sure it's going to left pad the date, well, let's pick a date. It's 1 digit here. And I keep forgetting to close down my console window when done. And let's rebuild and run. So I hit F9, put the shortcut there. And notice now it just left justified my date here. So it got rid of my flag to fill. So I don't like that. I'm going to remove that. Now I'm going to build and run. And I'm going to take care of the way that lines up with this. And I much prefer that look. All right, so that left justification flag was not necessary because the way we wrote it, this ends up left justified under this column heading because of the way we space things out. All right, so we can now uncomment our input. All right, so let's get rid of these default numbers. I don't really need these in here. You don't have to comma separate your variable declarations, but I'm doing this on the same line to make it more readable. Let's build and run again. Now we can enter our information. So our item number 583, our unit price, I'll do 12.5 instead of 13.5, /5/2017. I'm going to pick that as a date. And our output looks pretty clean. This has now been right justified. We've got our dollar sign. We've got our item number. All right, that looks pretty good. Now, there are some other things we could do if we wanted to specify that the user had to enter 2 numbers for the month and the date. We could change some things here. What if we put a 2 here and a 2 here and a 4 here? All right. Does that change the way our program runs? So now, all right, item number 583, make up anything you want, 13.5. What if I type the date as we did before, 4/5/2017? Everything still works out. What these say is they say use a maximum of 2 places. Use a maximum of 2 places there and a maximum of 4, right, to pick out numbers. Right. So that way if the user types more, it's only going to use the 2 that we specify here. It really isn't necessary. Right, we really have to depend on the user typing things correctly at this point. We can't error check. C is not a language that was meant, for a lot of data input. There are better languages now for that, but 583, let's try our big number, 9,999.9, and let's just say, well, what happens if I type 04/05/2017? Does that still work? Yes, that still works. There's our item number. All right. And we could do other things too. We might want to try to restrict what they type in, number of places for unit price. So let's run this one more time. Let's run. All right. Oh, fuck. I'm just going to make up some stuff. So unit price, I'm going to make that be 12345.67. Now that's bigger than our 9,999.99. And 4/5/2017. All right. Now we said we wanted to restrict this to 9,999.99. So can we do something here? Can I say, well, let's only let them put in 6 digits? And stop that from running. Let's compile this. No compilation error, build and run. All right. There's my number here, 12345.67. All right, so that took the 12345, but it didn't read in my 0.67. Well, actually, it ended up reading in my 0.67 here, because I restricted this to 6, which included the decimal point. But we said then that we had 8 numbers, right? 4 for 9,999. Decimal point is 5, and then 2 more places is 7. So what if I made this 7LF? All right, so 1, 2, 2, 3, 4, 5.67. So I got my 1, 2, 3, 4, 5.6, but I didn't get my 7. My 7 ended up over here. So I need to make this now. All right, so 1, 2, 3, 4, 5, 6, 7. I actually need to make that. Hey, oh, yeah. Control C kills that. All right, so I want to restrict that. If I make it A, I'm going to show you that we actually get in the 1, 2, 3, 4, 4. So there's my item number. So now I get 1, 2, 3, 4, 5.67. Right. And 4/5/17. And so now we get this big number, but we said we didn't want that big a number. So if we go back now to our 7, all right, our 7 came from 1, 2, 3, 4, 5, 6, 7. So what happens if we now enter 583, 9,999.99, and 4. Notice it reads in the whole number. Right? If we enter numbers bigger than that, it's only going to read part of the number. So you can do things then to specify here how much information you want to read in. Unfortunately, you can't specify the number of decimal points, right? Because here we can't say 7.2 and include the decimal point. So if I say build, if I compile, I'm going to get an error here. Warning, unknown conversion and type character and format, too many arguments for the format, right? It can't handle the decimal point here. So here I can specify basically the width of the number. It knows it's going to be a floating point. It's going to count the decimal point as one of those. So we took a fairly simple example and made it fairly complex with all these different things. I just wanted you to be aware of some of the different things that you can do with these specifiers. Right? For us, we want to do more computation. As electrical engineers, we're going to be geared more toward the hardware aspect. but I wanted you to be aware of what printf and scanf can do in terms of making your information look nice, restricting the ways it reads things in. So that's it for the end of exercise 6 in this case.